Okay, folks, so for those of you that are not in class today, we are going to be wrapping up Lab 4.3. We kind of had to rush through this one, so I wanted to just kind of review what we would have done in lab on Friday and what we should have seen. So if I play the video here, I'm going to move us up to about here so that we can see the end result. So as you're watching this, you can see that one of them is dissolving more than the other. This one should have been our potassium nitrate and this our sodium chloride. So we are heating up the solution, so we're increasing the temperature of the solution, which is allowing it to dissolve.
So at this point, one test tube has completely dissolved, and then we remove our rod. Now we show the taking part of that. We're going to make observations now.
So keep an eye on this test tube here and look at what is occurring on the bottom. You should be seeing crystals precipitating out of solution. So they were once dissolved and now they're coming out of solution. Okay, so the big thing to note on that also was the crystal shape. They should have been nice long pointy needles, and then your sodium chloride is going to be more cube in shape. So those are the two different crystal shapes that we should note in that lab. So then we are going to wrap up with our conclusion today in class, and then we're going to further investigate what occurred during the lab. So one of them completely dissolved, and then why? That increase in temperature allowed more of that solute to dissolve in our water solvent. So how does temperature affect the solubility of solids? As the temperature increases, our solubility also increases. That means as the temperature goes up, we can put more of our solute into that same solution and it will dissolve. So then we are going to introduce this solubility chart over here. So these are the main three solutes that we'll be working with. We'll investigate a couple of these in our next lab, and we'll look at their solubility in solution. So just one thing to note, what do you notice about it? First of all, note the axis labels that we have. So we've got temperature in degrees Celsius on the bottom, and then on our y-axis, we have solubility, and it's always got to be converted to this 100 centimeters cubed of water. So whenever we want to use this chart, if it's not already in 100 milliliters or centimeters cubed, we have to convert it there. So that's where we use that method on our worksheet prior, our concentration conversions. So again, you can find it like you find your grade or set it up like a proportion and cross multiply. So that is extremely important when using this. It's got to be in 100 centimeters cubed or milliliters of water. The other thing, as our temperature increases, our lines are also increasing. Sodium chloride is ever so slightly increasing, but it is increasing as temperature goes up. So that's the big thing. For solids, solubility increases as we increase the temperature. All right, then looking more specifically at our lab. In lab, we used 5 grams of each solute, so 5 of potassium nitrate and 5 of sodium chloride. So sodium chloride's our yellow line, potassium nitrate is our blue. So if we convert that to 100 milliliters, we'd have 100 grams of each solute in 100 milliliters. So if we find that on here, that would be 100 grams. And if we follow that across to room temperature, so if we're looking here, we have 100 grams of each of our colors, each of our blue and yellow down here. So if we are above the line, we'll talk about this a little bit later. If we are above the line, we have excess solute. Okay, so anytime you're above the line, you have excess. So looking at our chart, we're above the blue and we're also above the yellow. So both of them would have excess setting at the bottom of our test tubes when we started. As we heat that up, we heated it to near boiling, so that's about 100. Now, we still have an excess of sodium chloride, but if you look up here, we are under our blue line. So we are unsaturated. So we could add more of our potassium nitrate if we wanted to, but our goal was just to get one of them to completely dissolve, which it did as we increased it to boiling. Okay. We continue to heat it and it becomes unsaturated where it can hold more. But when we cooled it down in our cool water bath, so again, we're here and we're cooling it down below room temperature. So again, we have a precipitate. We've got more in our solution than it can hold at that temperature. So at this point, now we have a precipitate because it's coming back out of solution and then it's going backwards. So if you think about it, we pushed it this way to get it to dissolve, and now we're pushing it the other way to get it to come back out of solution to crystallize. All right, so these dots are just illustrating that as we move across, okay? And if we speed those up, we come over here. So again, we had 100 grams and we heated that up. So this is that solubility chart that we're going to be using. You should have this in your packet. I would encourage you to color code them. If you use the same colors as this one has, great. If not, just color code it. That way you can see those lines and you're not getting crisscrossed when they overlap. Okay. So again, how to read the chart. If it is below a line, so here we're looking at our pink or our red sodium nitrate. If you are under the line, you are unsaturated. Okay, so it's not saturated. We could add more and it would dissolve. If you are right on the line, you are saturated. And if you are above, you would be saturated with excess. So if we have 130 grams of potassium nitrate, in our 100 centimeters of cubed of water at 40 degrees Celsius. So here's 130, and then we're at 40. So right here where this arrow is pointing, that's where our solution would sit. And then the question is asking, is the solution saturated? So we're looking at our blue line where the blue arrow is our solution saturated? Yes, it is saturated, so much so that it's saturated with excess. Okay, so we are above the line, we're saturated with excess. So that's what this blue shaded area is showing. If we are above the line, we are saturated with excess. Okay, so we've got too much. This is like your bowl of cereal. If you add sugar to your milk in your cereal, if you've got sugar resting at the bottom, you've got excess sugar. The milk can't hold any more sugar. It won't dissolve, so it'll settle to the bottom. Okay. And then we're just going to go through some of these questions. So just work through these at your own pace. Just make sure that you understand these concepts that we're talking about. So question 1, what is the saturation point of sodium nitrate at 50 degrees Celsius? So all you need to do is come over to the bottom, our x-axis down here, find 50 degrees Celsius, and then you're going to follow that up until you hit our sodium nitrate line. So again, right on the line is going to be saturated, perfectly saturated. We've got a happy solution. We don't have too much, and we don't want to add any more. It's perfect. It's happy the way it is. So at 50 degrees Celsius, the saturation point, then we follow this over and we're going to have to kind of estimate. So this line is 115, so it's about 118. So 118 grams of sodium nitrate will dissolve nicely in 100 centimeters cubed of water. You've got to have all of that. I know it's a mouthful, but you've got to have all of that in your label. Otherwise, it looks like a density label. So make sure you include the solute. So sodium nitrate is what it's asking, and then the water. Okay. Second question. If we were to cool this down, so again, we're at about 118 at 50 degrees. If we cool this down to room temperature, how much would precipitate out? Okay, so follow me here. We're at 115 at 50. We're going to move down to room temperature, so about 20 degrees. We're still looking at our pink line, so there's two ways you could do this. Take 115 and subtract, this looks like it's about 87, 86. So take 118 minus 86, and that difference is going to tell you how much would precipitate out. Or you can simply count. So each of these lines is 10. So we've got 10, 20, and then we've got a little bit here, maybe 24, and then a little bit here, about 20. What do we want to say? 20. Oh, sorry, it's going by fives. No, tens. Yep. So, sorry. You've got 24 plus about 23 or 28. Just add those together, and then you've got your difference again. Okay? So you can either do the subtraction or simply count your lines. Okay? Question 2. If you have 80 grams, so these are very similar. You're just reading your chart. 80 grams, find that. 80 grams, and potassium nitrate is our blue line, and we're at 60 degrees. So you'd find that spot, figure out if you're saturated, unsaturated, or oversaturated with excess, and then, so here's our point. We're right here. And then question, or part B, what temperature would we need to cool it to so it would become saturated? So follow 80 over until you land right on that blue line, and that's the temperature. So follow it down and estimate that temperature. How much more could you add to become perfectly saturated? So if we stayed at our 60 degrees with 80, how much could we add to make it a happy saturated solution? So again, we're at 80, we're going to count 10, 20, and then estimate about 29. So about 29 grams would make it a happy saturated solution. Okay. All right, then if we cool this down to room temperature, so we're back here again. If we cool this down to room temperature, about 20, how much would precipitate out? So this time we're counting down to our blue line until we meet it, and that's your precipitate. Okay. All right. These then are working with strictly our sodium nitrate line. So again, just reading the table. What's the solubility of sodium nitrate at 55? So here's 55. We follow it up to our pink line. Here we are. We're not quite right on the middle there. We're slightly below 120. Okay. So same thing here at 35, and then again at 65. Just reading the chart. Okay. Here we're looking at this position on the chart, answering our question. Then you're looking at precipitate out again, so counting down to the line. And then if you have 100 grams of sodium nitrate, our pink or red line, at 20 degrees Celsius. So room temperature, we've got 100 grams. Okay. What temperature do we need to heat it up to totally dissolve it? So we're going to follow over till we meet our pink line, and then we're going to go down and estimate our temperature. Okay. Then you are going to work on your packet sheet. So there should be a sheet inside your packet that you can try. If you have any questions on those, please shoot me an email. I'll try and help you out as best I can, or we can set up a Zoom after school today. We are also going to be sending home a worksheet that you can be working on. And there's just a few questions on there that I'd like you to work through. So if you guys have any questions, please let me know. The homework for tonight is to do the pre-lab for our next lab. So that will also be posted on Canvas here in a bit. So let me know if you have any